Greetings, mathematicians. This is Mrs. Mouse, and I know this is going to be your first video of the year. What I'd like to start off with is a couple Laffy Taffy jokes. So here we go. All right, here we go. I know those are kind of bad, but I just really enjoy Laffy Taffy jokes. All right, I'm going to get my screen set up here for us. And we are going to cover like terms today. Now you're going to grab your packet and fill out a few notes. I'm going to go over a few examples, and then you're going to work these out on your own here today. Okay, so the topic here, this is on page 2. It should say, you should see part of an expression. So the topic is going to be combining like terms. Now, at any point in the video, you can pause this. If I'm going too fast, that's what's cool about a video. And then if kids are absent, they're able to watch the video and get caught up. And so this is just algebra. Now I'm just putting a 1 there because I know this is the first video that I am making for you. All right, so it's really important that we know the different parts of an expression. Now notice there's no equal sign. This is just an expression that we want to simplify. So that's what word you would see. Okay, so you wouldn't see solve. Something like this, you're going to see the word simplify. Now you can see we have all of these terms, and some of them are the same. So how do we know if they're the same or not? Well, we look at each of the terms, and if they have the same letter with the same exponent, we know that they are like terms. So let's get all the variable terms listed from this expression up above. So we have 7x, negative 5x, and we have 4x. So those are all the terms that have a variable. The constants, those are terms without a variable. We call those constants. We have 3, we have 8, and we have negative 1. So make sure if it is a negative that you include that in front of that number. All right, now on the variable terms, we talk about the coefficients. Coefficients are important because that's what we end up combining to simplify. So the coefficients, we have 7, we have negative 5, and we have 4. And so those coefficients will let us know, hey, how are we going to simplify all of those x's? Okay, so let's get to it. Combining like terms. So it's the same expression here. Now, there are so many ways to organize this. You really just have to find the way that suits best for you. Okay, so here's the different ways that I've seen kids do it. I've seen other teachers do it. I do a lot of these different ways. One way is to underline. Another way is just to draw arcs to those like terms. Another way is to rewrite. So it's like, wow, you know, you just need to find the method that works best for you. So I'll try to show you each of those, and whatever suits you best, you make sure that you do that. I'm going to do the underline. I'm going to underline all my variable terms. Now, some kids can do math in their head. Some kids have to write more work down. Okay, again, you just have to know how you best will get the correct answer. If I underline these, though, I can go 7x minus 5x. That simplifies to 2x. 2x plus 4x is 6x. Now, I also could draw the arcs. Okay, I could connect those. That would be another method. And then I could rewrite this. Okay, over here I could go 7x minus 5x plus 4x. So again, you just kind of have to find that method that works best for you. Now, in the constants, I like to circle the constants. Again, we could draw arcs. You could use two different colors. I've seen that too, where kids use two different highlighters. Let's see what that ends up simplifying for us. 3 plus 8 is 11. 11 minus 1 is positive 10. So we need to make sure that we put that sign there. If it's positive, if it's negative, we can't just leave this blank. So you're going to see we end up with two terms for a final answer. Okay, we don't end up going, oh, 6x plus 10 is 16x. Think about those algebra tiles. X tiles are different sizes from the little individual tiles, and they stay separate. All right, I want to go over number 5. Okay, so let me get it on my screen here a little bit better. Okay, so again, decide on what method you want to use. I'm going to underline my 7p, my minus 9p. Okay, I can rewrite it, 7p minus 9p. All right, so I know I'm taking away more than I have. So in my head, I'm thinking, oh yeah, that's going to be a negative value. I have negative 2p. Again, you can draw those arches. Those two go together. I'm going to circle the constants. Negative 1 plus 5. I know some of you could just go ahead and do that in your head. I'm thinking, oh, I have way more positive than I have negative. Those are opposites. I'm going to subtract them. I have positive 4. Flip to the back side. I'm going to do a few on the back as examples. Now, sometimes we end up having, just like on the algebra tiles, we have squares. And again, we just have to get those terms together. So you're going to notice on number 9, both of these are values, the variables have an exponent of 2. They're like terms. These both have an exponent of 5. They are like terms. I'm going to go ahead and work out number 12. So let's take a look at that one. Now, as I'm observing this expression, I see that I have 3 different terms. I have a squared term. I have a term that would just be to the first power. I have a constant, and then I have a squared term. So I have in my head, unless I have 0 pairs, I'm going to have 3 different terms in my final answer. I'm going to double underline this one just because it has an exponent of 2. And again, if you want to, you can draw the arcs, whatever you need to do. If you can do this in your head, great. Otherwise, just off on the side, we go 8k squared minus 2k squared. We look at the coefficient. 8 minus 2 is 6. And you can see it just stays k squared. We don't change it. Just like on the algebra tiles, they didn't automatically suddenly change to some different shape. I'm going to single underline anything that's to the first power. Now don't forget the coefficient would be 1. If that helps you, write it. Negative 1k minus 5k. Okay, I'm thinking in my head, same sign, add them together, sign stays the same. I say that all the time. So I have negative 6k. And then I just have that one constant, but that's still part of our answer.
Good morning, Black Raiders. Just a friendly reminder that we have our first.
All right, last one I'm going to go over here is down at the bottom, the geometry applications. I'm going to go over number 18. Now, what the direction says is give the perimeter. All right, so perimeter breaks down to peri, means around, and meter means distance. So it just means distance around an object. And I'm going to go ahead and go over number 18. It is a triangle. It has 3 sides. We are going to add the 3 sides. Now I'm just going to write it in one long expression here. And notice I'm adding all the sides, but I made sure I had a negative on the a, I had a negative on the 1. Now again, before I even solve this, I can see I have 3 different terms here. I've got this 4ab that doesn't go with anything else. Just double line that one. I have this 5a that goes with negative a. Remember, there's a 1 there, if that helps you. 5a minus 1a is a positive 4a. And then my constants, I have a negative 1 and I have a 17. Negative 1 plus 17 would give me positive 16. All right, now what I want you to do is work on the rest of those problems. So both front and back. If you have any questions, make sure that you ask.